Let's work through this geometry problem carefully and keep track of exactly why each step works. We have rectangle JKLM, and inside it there is a circle touching the top, bottom, and left sides of the rectangle. The circle touches the left side at point T. On the horizontal diameter of the circle, the right-hand endpoint is U. A slanted line starts at T, passes through the circle at V, and continues until it meets the right side of the rectangle at W. We are told that TV is 8 units and VW is 4 units, and our goal is to find the area of the entire rectangle. Let's begin by introducing the radius of the circle. Suppose the radius is R. Because the circle touches both the top and bottom sides of the rectangle, the distance from the top of the rectangle to the bottom of the rectangle is exactly 1 diameter of the circle. In other words, the height of the rectangle is 2 times R. Now notice that TU passes directly through the center of the circle, so TU is also a diameter. Therefore, TU equals 2R. Next, extend this same horizontal line from T through U until it reaches the right side of the rectangle. Let that intersection point be N. We are going to call the part outside the circle from U to N, X. Since the complete horizontal distance from T to N consists of the diameter TU plus the remaining segment, UN, we can write Tn equals TU plus UN. Substituting what we already know, Tn equals 2R plus X. Keep that expression in mind because it represents the full width of our rectangle. Now we need one important geometric idea. Join V to U. Since TU is a diameter of the circle, an angle formed by the endpoints of a diameter, and any point on the circle is a right angle. This is a theorem commonly known as Thales' theorem. Therefore, angle TVU equals 90 degrees. Now look at the other triangle. Since TN is horizontal and the right side of the rectangle is vertical, these two lines are perpendicular. Therefore, angle TNW also equals 90 degrees. So we now have 2 triangles that contain right angles. The first triangle is triangle TVU, and the second triangle is triangle TWN. Notice something else very important. Both triangles have the same angle at T. The angle is formed by the same horizontal line and the same slanted line. So angle VTU is equal to angle WTN. We now have 2 equal angles. One pair is 90 degrees, and the other pair is the common angle at T. Therefore, by the angle-angle similarity rule, triangle TVU is similar to triangle TWN. This similarity is the key to the entire problem. Because the triangles are similar, their corresponding sides are proportional. The correspondence is TV with TN and TU with TW. So we can write TV divided by TN equals TU divided by TW. Now let's substitute every value we know, one step at a time. We are given that TV is 8. We know that TU is 2R because it is the diameter. And what about TW? The entire slanted segment from T to W is made up of TV plus VW. We are told that TV is 8 units and VW is 4 units. Therefore, TWs equals 8 plus 4, which gives us 12 units. We also know that Tn equals 2R plus X. So our proportion becomes 8 divided by the quantity 2r plus x equals 2r divided by 12. Now let's solve this proportion. We cross multiply, which means we multiply 8 by 12 on one side and 2r by the quantity 2r plus x on the other side. This gives us 8 multiplied by 12 equals 2r multiplied by the quantity 2r plus x. Now calculate the left side. 8 multiplied by 12 is 96. Therefore, we have 96 equals 2r multiplied by the quantity 2r plus x. At this point, don't worry about finding r or x separately. In fact, we don't need to find either one individually. Look carefully at what the two factors represent geometrically. The quantity 2r is the diameter of the circle. Since the circle touches both the top and bottom sides of the rectangle, this diameter is exactly the height of the rectangle. Meanwhile, the quantity 2r plus x is the entire horizontal distance from T to N. That is the full width of the rectangle. So our equation, 96 equals 2r multiplied by the quantity 2r plus x, is really saying 96 equals height multiplied by width. And what is height multiplied by width? Exactly, it is the area of a rectangle. Therefore, the area of rectangle J, KLM, is 96 square units. Notice how we never actually needed to calculate the radius or the width separately. The similarity of the two triangles gave us the product of those two dimensions directly, which is exactly the area we were looking for. So, the final answer is 96 square units. If this solution made the geometry easier to understand, take a moment to like the video, subscribe for more geometry problems, and leave a comment with the next type of problem you would like to see.